Yes, in today's session, we will start with understanding what is normalization, why normalization is required, and how to perform normalization using different forms of normalization. Okay, we have something called first normal form, second normal form, and third normal form. With that, using those three different normal form, we will see how we can do the database design. Next, we will see the different types of constraints that are available in relational database management system, and also we will see the advantages of creating that constraints at the table level, at the database level. Followed by this, we will perform the data definition language, and we will perform the DML operations. In addition, we'll cover the different types of joins in SQL with some demo data. First of all, what is normalization? We'll start with normalization. So what is a normalization? It is a database design technique. Before you develop any application or any software or any application or any product, you need to have the data model in place. As part of software development life cycle, before you proceed with building application or something like that, you need to have the data model design should be there in your hand. Without the data model, you cannot develop the application. Even if you develop it, it will be in mess. Okay, similarly, right, so it's something like blueprint. Before you build a building or before you construct a house, you need to have the blueprint. Without having the blueprint, if you construct the house, what is going to happen? Right? So that's the reason why data modeling should be done first, and then only the application development has to be done next. In order to do the database or data model design, we use a technique called normalization. What exactly normalization? What we do in normalization? So in the case of normalization, we divide the larger tables into more than one smaller tables and link those smaller tables using relationship. That is what we do it as part of normalization. The question is, why should I do normalization? It is a technique. Normalization is a technique using which we do the database design. With normalization, if you do the normalization or if you do the proper database design using this normalization technique, you can eliminate data redundancy, you can improve the data integrity, and also you can overcome certain anomalies like insertion anomaly, update anomaly, and deletion anomalies. These kind of anomalies you can overcome. Okay, now you understood the repercussion. If you don't do the normalization, these are the issues that you will be posing it, right? With the normalization, you can avoid this kind of issues. Before we proceed with understanding how to perform normalization using different types of normal form, let us first understand what exactly the insertion anomaly, update anomaly, and deletion anomaly with this simple data set. In this data set, we can see that the employees are working in different departments. These are the three departments are there. For these three departments, almost 3 or 4 employees are working. 3 employees are working. We could see that some employees are working in. Okay, but here we can see that John is working in CIS department, but his employee is 456, and the same John's record repeated more than one time. There is a redundancy here. But when you look at the student group column, this employee got assigned to 2 different student group. You might be wondering, what is this student group? Is employee, why student group is coming into picture? Let's say this company is recruiting. They recruited freshers. They recruited maybe 100 freshers. They want their employees, the senior employees, to give training to those freshers. What they did, since one employee cannot give training to all the freshers, they created those freshers with different groups. You just think that way. Longfellow is the one responsible for training this freshers group, and Birek is the one responsible for training marketing club group, and so on. Let's see, this training program is planned for 2 months. After 2 months, the training program is over. So after the training program is over, all the freshers, the eligible freshers, okay, and they will get assigned to the respective department. So once they get assigned to the respective department, we don't need this group any longer. You wanted to delete this group. So let's say you are in the pursuit of deleting this group. So what you are doing is you are using this command at the database level. Delete from employee. This is an employee table. The table name is employee. Delete from employee, where student group is equivalent to beta, alpha, something like that. If you delete this, what will happen? This group is no longer required, but the employee is required for my company. The employee data and the department related data should be still, these two information should still persist in my database. Just because you delete this one with the impression of deleting the group which is no longer required, you are deleting the important other information from this table unknowingly. Not only this one, look here, another student group with the same name got assigned to John. Even the John information will also get removed from this table. This is called deletion anomaly. By deleting one value, you are removing other important information or the important data from this table. Deletion because you are storing all the data in a single table. Okay, next one is update anomaly. So what is update anomaly? For example, recently John got assigned to marketing department. So we need to update his department in this database. Since we have more than one record exists for John, when you try to update this one, let's say if you are updating John with this based on a student group, update employee table where department is equivalent to marketing, where student group is technology org. If you give this, only this in this record, the department name will get replaced or will be overwritten as marketing for John. This update is not complete. This update is not complete. Why it is not complete? One more record is there for John. There also that in that record, his department is different. But you will be under the impression, I already updated his department to marketing. But still, there is some anomaly. In that case, you need to find out, okay, what other records are there, what other records exist for John in this table. You need to search for it, and then you need to replace all the records which were redundantly stored in this table. Right? You need to identify and then you need to update all those things. That is unnecessary pain. Okay. So this is called the update anomaly. Another thing is, let's say you remove this. Let's say you are with the intention of deleting this group. You remove this one. Let's say a new employee is joining the company, and we want to assign that employee to accounting department. First of all, you don't have any record for the accounting department in this table. So in that case, how can you assign him to this one? This is insertion anomaly. So in this case, the table design is not good, because of which all these anomalies are happening. So how do I overcome these insertion, updation, deletion anomalies? By doing proper database design, we can address this issue. In order to do the proper database design, you need to apply the normalization technique. So what are the normalization technique? There are three different normal forms are there. First normal form, second normal form, third normal form. In the case of first normal form, the table, it should have unique records in it. All the rows in your table should be unique. In addition to that, you have another rule. Each cell must contain an atomic value, single value. It should not have more than one value in each column. Remember these two rules. Very simple one. Now, let us see how we can perform first normal form with this table. Okay, let me do one thing. I just made a mistake here. Table. Let's start this with this table. In this case, the customer John, he has more than one record in this table. At one point in time, you wanted to know in which order John ordered fries and Coke more than one time. Okay. See, first of all, we have a duplicate record for John, but we do not know whether it's a duplicate. So there could be chances the same customer might order the same product in the future, or you would have ordered the same products in the past also. But we have duplicate records here, right? We have redundancy here. John, it's not unique. The rows are not unique here. It is violating the first normal form. The first rule of the first normal form is all rows must be unique. And the next one is all the values or each cell or each column, you have to have atomic value, single value. You are not supposed to have more than one value. Look here, John is a single value. His name could be John Andrew or something like that, but still it is a single value. It represents only one person. Whereas in this column, products, we have more than one products are there. We have more than one products are there. It is also against the first normal form. Each cell must contain single value, but here we have more than one value. So here we don't have unique records, and on top we have more than one value stored in this column. Hence it is violating the first normal form. How can I address this one? Okay, so the next, how do I address this one? So the next step is, what we will do is, we are going to create or introduce a new column by the name of order ID. With the order ID column is it has a unique value in it. It should not have, see in this case, it has a unique value in it. Somehow we are able to address this issue, right? So all rows must be unique. Yes, now it is unique because of the order ID. With this order ID, we are able to find out in which order John ordered fries and Coke. In order ID 1 and 3, John ordered fries and Coke. With this order ID, we are able to identify an unique instance of the row. Fine. The first rule of the first normal form now satisfied after introducing the order ID column here. In this order ID column, we have unique values. Good. With this unique ID, we are able to identify uniquely each transaction. But still, this problem persists. Each column, we should have only one value here, but we are having more than one value. How can I address this one? So one solution is I can remove this column from this table. I can store it in a separate table. Another possible solution is I can create two columns, one column to hold fries and other column to hold Coke. That is fine. But when it comes to this customer, let's see if this customer ordered 20 products, fries, nuggets, Coke, peanut butter, so on and so forth, 20 products. Let's say you have 100 customers. Just because one customer, Mike, ordered 20 products and rest of them ordered maximum 2 or 1 or 2, maximum 3. Okay. So except this guy. This guy ordered 30, let's say 20 products. Just because one guy ordered 20 products, we cannot create 20 columns. Even if you create it, for the other records, all the 20 columns will not be filled with the data. It can lead to some kind of sparse matrix. So we cannot create many columns for each and every value in this column. So what is the way out now? So only way out is we need to break this table. This column we need to break this from this table. So now I am going to store this in a separate table. Instead of creating multiple columns, I am going to store it in a single table with a single column. But here what happens is I store fries in the first row. In the second row I am going to store Coke. And third row I am going to store fries. And fourth row I am going to store nuggets. Fifth row I am going to store Coke, and so on. Okay, I stored it. So how do I know which products ordered in which order? Which all products got ordered in which order? How do I know that? In order to know that, I am going to store the order ID along with this products table. Fine. Order ID I just stored along with this column. And also I created a link between these two tables. So order ID and order ID. So as in order ID, so let's say John, the customer John, his order ID is 1. In this order ID 1, fries and Coke got ordered. In this case, the products, each cell has only one value in it. Each records in this table are unique. In this table, each values are stored in a separate row. Now the question is, here the values are not unique here, right? You might be asking this one. But here it is a kind of a composite key, order ID and fries both put together, primary key. Primary key is nothing but unique key. So unique key you can create it based on a single column. Instead of saying unique key, primary key column will hold unique values in it. You can create a primary key based on a single column, or you can create a primary key based on more than one column. So in this case, the order ID and products, these two are composite key. For one fries and for the order ID one Coke. Whereas here also the Coke is there, but the order ID is different. With the combination of these two, we can identify specific record. So that, for example, John has ordered fries and Coke, right? The very next day he is going to cancel Coke. So in that case, only this record will get deleted. Still this record will remain as it is. It will not get disturbed. Here there is no deletion anomaly. But if you store it in a single column, what will happen? He wants to delete Coke, but along with this entire order ID, the customer, everything will get deleted. So now you understood why we need to decompose or divide or break the tables into more than one table to address insert, update, anomaly, deletions. Fine. The next one is second normal form. Now let us look at the second normal form. So what the second normal form says is, if the table or if the database has to be in the second normal form, first of all, it should comply with first normal form. in addition to the first normal form, all the non-key columns should fully functionally dependent on key column. So let us take other data set. In this data set, student ID and course ID is there, and I have course fee column here. Here the first rule, yes, first rule should be satisfied. All the rows should be unique, and also this one, each column should have single value. So each column have single value, but here the rows are also unique. For example, it's a composite key, student ID and composite key, course ID. These two are, let's say, the composite key. These two columns forms a student. One student take only the course ID 1, and the same student in this record the course ID is different. Okay, so the course fee is 500,000. So in this table, these two are key column, composite primary key. Okay, and this is a non-key column. The non-key column should fully be dependent on the primary key column. Let us assume that, let's this is a primary key at this moment. Okay, this column is a non-key column. This is not a primary key column, right? The course fee can repeat more than one time, hence it is a non-key column. This non-key column is not fully dependent on student ID, whereas the course fee is fully functionally dependent on course ID column. Okay, so for course ID the fee is 500. For the same course ID the fee is 500. We charge for another student also. For all the student, for the course ID 1 the fee is 500. If I remove course ID here, and if I say 500, course fee is 500 for student ID 1, and if I say 1000 rupees fees for the student ID 1, does that make any sense? Course fee is not in this case fully dependent on the student ID unique column, whereas it is fully dependent on the course ID. Okay, with the course ID itself, you can find out each student how much he paid for the specific courses. So in this case the course ID is fully dependent on that, but if you know the course ID, you will be able to get you can derive the value from the non-key column. But in this case, if you know the course ID, you can derive you can make a guess what is the fees. Even in this case, there is a partial dependency exists between these two columns. There should not be any partial dependency between the key column and non-key column. If there is a column exists in my table, it should be fully dependent or fully functionally dependent on the key column. But this is not fully, whereas this one is fully dependent on this one. Hence we need to break this one. It is against the second normal form. Hence we are breaking this column from this table, because this column is not fully dependent on the student ID, but it is depending on the course ID only. Hence I am going to remove this one. So student ID, course ID, but if you break this column, you will have only course fee here. But in order to identify which course fee is related to which course ID, you need to have the course ID column. Hence you need to have this one. But for this, in this table, to know which student is undergoing which course, for that you need to have the course ID. So now the next step is you need to see both tables. Now both the tables do not have any partial dependency. This one is fully dependent on this one is fully dependent on this one. There is no partial dependency. Hence it is in second normal form now. Okay, and you can link these two tables based on the course ID in order to query the data from these two tables. Next one is third normal form. In the case of third normal form, if a database has to be said that it is in third normal form, it should fulfill these conditions or these rules. The first rule is it should comply with both the first normal form and second normal form. In addition to that, any non-key column should not depend on any other non-key column. You know what is unique key, what is non-key, isn't it? Student ID is the unique key, course ID is the unique key in the other table. But a non-key column should not depend on any other non-key column. For example, in this table, employee ID, employee name, zip code is there. Forget about this is zip code. And if you know the zip code, you can tell the state. And also let's say city and district. Okay. So in this case, the employee name is fully dependent on employee ID. And the employee zip also, employee ID is dependent on the employee ID. So this guy is living in so and so place and zip ID is required. Whereas if you look at this non-key column, employee, state, the state, city, district, all these three columns are fully dependent on this one. Okay, this is a non-key column. These are also non-key column. There is a dependency between the non-key columns. Hence, it is violating the third normal form. You need to break this three columns into a separate table. And again, so in order to identify, in order to relate this one with this table, you need to have the employee, the zip code should be there here. Okay, zip code, employee, state. So now you understood how we address the third normal form. In the case of the third normal form, we have broken all the non-key column which was dependent on the other non-key column. Okay, and also to link these two tables, to form a relationship, we need to have a common key column. Hence, we store the zip code here. With this zip code, we can link with this table to query the data from these two tables. Suppose you want to query the employee name and his city and district and state, you need to have a relationship. The relation should be based on the common key column between these two tables. Okay. So now you understood the fundamentals of normalization, the first normal form, second normal form, third normal form. Next, we will move on with understanding constraints. Let me just say